Okay, let's assume we have a gain stage here, and you have an input in a DC value, around the DC value, and the peak-to-peak value is 10 millivolts. That means it goes up 5 millivolts and goes down 5 millivolts. And the pink one is your output. When your input goes up, your output goes down. That means when this goes up and when your output goes down, or vice versa, when your output goes up and your input goes down, that makes the gain negative. That's all there is to it. And now we need to look at the gain. The gain is how much the input is amplified at the output. So your input is 10 millivolts, your output is 30 millivolts, so your gain is negative 3. Well, in this case, the DC value of both signals were the same level. What if they were in a different level? What if we had something like this? So now we have the input, again 10 millivolts, but this time I drew it as output as 10 millivolts. So let's first decide if our gain is positive or negative. Input is going up, output is going up, so they're in the same shape. So gain is positive. So if you're thinking the gain is 2, you're wrong, because that's the DC value. This signal can be anywhere. Depends on your DC values. It does not affect the gain per se. All you need to look at it is these values. How much is output amplified from input? So output divided by input. 10 millivolt, 10 millivolt, your gain is 1. You cannot say there is no gain. There is a gain and the value is 1. Now let's see what our ping pong racket is hiding. Ooh, now the input is higher and output is lower. Can it be possible? Yeah, why not? So your input is going down, your output is going up. It doesn't matter if your input starts to go down or go up. All it matters is that they are in the different polarity. There's a phase shift. So your gain is negative, for sure. And now you look at your amplitude. Your input is 10 millivolts, your output is 30 millivolts. So your gain is negative 3.